So I'm recording this video for those who would like to use the fiber photometry analysis pipeline and need a bit of guidance with loading the Python codes. So if you click the link from the Argotech website to download the analysis tools, you'll be prompted to this Google Drive. You need to click on the analysis pipeline and download this folder here entirely. So while that folder is downloading, we can also open our Anaconda Navigator. You can use any kind of Python interpreters or softwares you'd like. I use PyCharm, but I think Spider is a bit more click and play user-friendly. So we'll launch Spider. And because it's running through Anaconda, all the dependencies that we need will be preloaded into the software. So once Spider is loaded, we can now open up our downloaded analysis file. So this is delta effer and p effer, and we'll just unzip that. Once unzipped, you can actually run it directly from the downloads folder, but I would move it somewhere like your documents so that it's a bit easier to find later. So now the documents folder has the deffer and peffer with all the files within it. So we go back to Spider, and we can go to Projects, New Project, and now we click Existing Directory, and we define the location to where we just moved it to our Documents folder. So we go to Documents, we'll double-click here, and click Open, and we'll go Create. So you know it's worked when we can see the default directory over here. So the analysis pipeline has two different functions. One's for a simple delta F over F calculation, and the other is to detect peaks. The peak detection script requires a bit of coding know-how to calibrate the settings, and so I don't recommend running it as is at the moment. But the delta F over F calculations are quite simple. From here, we load the deffer homepage, double-click that, and a very, very short code will pop up. We can get rid of the temporary Python file here. So once the homepage is loaded up, we just click play or run, and it will open a little pop-up window asking us to choose a file. It will automatically look for folders, look for files within the raw data folder within the directory. So here I already have some example data that can be analyzed. We'll run number 1 and click open. And there'll be a little chat box here asking what you'd like to do, and we'll say yes to the analysis. So I go Y and then enter. This will then prompt the processor, and it will load the data here. So this will be our full script. Within the full script, you can choose if you want to analyze a certain window. And so you will have to enter those times into these text boxes here, which have just popped up. You can use these buttons here to look for exact time points that you want to analyze. But if you want to just run the whole window, just click OK. Once you clicked OK, there will be a series of different analysis options available for you. The gold standard method would be option number 1. And so this would be the fitting of the 405 scaled to the 465, and we're doing a simple subtraction from that. This will work 99% of the time. There are rare cases where I think the LEDs don't behave as normal, and so you may need option 2. With option 2, the 405 is again scaled to the 465 signal, but we are not running the linear bleach correction off the 405 itself. We're running that off the 465. What this ultimately means is that it will give you noise correction, but if there are changes to the baseline signal, if there's a drift in the baseline signal that is real, then it won't be able to detect that change. And the third option is essentially we're not doing any noise correction here, any fast noise correction, and it will only correct for slow changes. So on our analysis option window, we can choose which option we would like. I will go with number 1 in this instance and click OK. So now we get our final delta F over F data here, and our Z-score. The Z-score has been, it's the Z-score of the whole trace. So what we're actually seeing is some hypothalamic CRH neurons. So the animal has just been plugged in, so the activity is a bit high. The animal settled down. We have a short stress here, and then another stress here. And then at the end is the mouse being picked up to be sent back home, and that generates another peak, which we use as a normalization signal. So at this point, your data will be now in the results folder. So we can find that example data in the results. And if you want to load your next file, it will say ready for next file. Find that pop-up window for the file chooser, and you can select your next file. So if we run data number 2, click open, and again, we will just run that exact same process. So I'll leave it there. I hope this has been helpful. Ta.